All right, section 9.4 is on direct, joint, and inverse variation. All right, so direct variation is a relationship between two variables, x and y, that can be written in the form y equals k times x. Oh, goodness gracious. This is doing this. Where k is not 0, and it's called the constant of proportionality. So for a particular problem, it's going to have this number that's going to be the same throughout the problem. All right, so it's a constant. It's also called the constant of variation. All right, some of you guys were asking why we had these little smiley faces. So the first time I ever taught direct and inverse variation was when I was at IU. So some of you guys know I taught a couple years at IU. Usually I taught like pre-calc, but for one class I taught a basic algebra class. And that was because my friends and I had all been hanging out and we'd been playing cards the night before. And my friend Jason decided that he wanted to eat a giant thing of cookie dough. So my friend Megan was a very good baker. She had left like some raw cookie dough in her fridge. He saw it and was like, oh my gosh, can I have that? So he started eating it. And it was like, I'm going to finish this whole thing tonight. And this bowl was like this big of cookie dough. So he made it his goal that he was going to finish it. And about halfway through, he started to feel pretty sick. But he was like, I'm going to finish this. I don't know why guys do this, but he decided that he was going to finish this cookie dough. So the next morning, I get a phone call at like 7 in the morning, and he's like, hey, I'm really sick. I've been throwing up all night. Can you go and cover my 8 o'clock class? So I was like, yes. So it was funny because when I got in there, they were learning about direct and inverse variation. So we were laughing about their teacher, who is an idiot. And we were saying, you know, the more cookie dough you eat, the more your stomach hurts, right? So this is how direct variation is. So the more, like the higher x goes, the higher y goes, okay? The smaller x is, the smaller y is. Okay, so they're directly related. All right, the opposite of that is an inverse relation. So an inverse relation basically says the more one of them is, so the more y is, the smaller x is, okay? And the less y is, the bigger x is, okay? So that's the difference between direct and inverse variation. So can you guys think of different things that are directly related? So think of real life problems that are directly related. Oh, so I guess I didn't talk about the actual faces, did I? I talked about how my friend got very sick. But when you go to the doctor, do you guys ever see these little smiley faces? Yeah, so the smiley faces always drive me crazy. Even when I gave birth to my son Carson, they showed me the smiley faces, and they were like, yeah, they were like, how much pain are you in? And I was like, I want to die. But they always do these little smiley faces. They're always like, how, you know, what smiley face are you right now? And you're like, I don't know, I'm okay. I just came in for a cold. I'm a 0. Like, so you always have these smiley faces. So my friend was at 10 for the smiley face chart with his eating the cookie dough. So I would say the more cookie dough he ate, so the higher amount of cookie dough, the higher he was on this chart, right? So it's a numerical quantity. I know, he was struggling. All right, so what are some other things that are directly related? Nothing in real life. You guys can't think of anything. Okay, the less you have in there, the more you use your highlighter, the less bright it will be. So that's an inverse relation. Yeah. The more you drive, the less gas you have. That's an inverse. Good. Either. Yeah.
The higher you heat an oven, the higher it gets in temperature.
Okay. Yeah. The higher you turn the gauge on the oven, the higher the temperature is. That's a direct.
The more you spend, the more debt.
Yeah, the more you spend, the less money you have would be an inverse, or the more you spend, the more debt you have, right?
Stuff like that.
Someone said one that was really good one year that I didn't think about. Like they were really interested in the weather. So they said the more precipitation in the air, the more rainfall you will most likely have. I was like, oh,
I was
that's a good
really
one.
interested in weather.
I don't know. Oh, I have a weatherman friend. He's very interested in the weather. Any others? No, I mean, you could go really gross and you could talk about the more cookie dough you eat, the more puke he had the next day, you know. I mean, I've heard
The more
that. People
cookie
say
dough
that.
you eat over your lifetime, the fatter you get.
The more cookie dough you eat, the fatter you get, probably. Although I do love cookie dough.
Cookie dough's
Just,
good.
you know, I like it baked. I like the actual cookies, not the cookie dough. All right, so let's do some examples. So write an equation that expresses the statement, the cost C of a dozen wrenches varies directly as the price P of one wrench. Okay, so these problems are always going to have a K value. They're always going to have a constant. Okay, so the cost C varies directly, so that means if one goes up, the other one goes up, as the price P of one wrench. Can you guys think what K is in this problem? So the price P of one wrench, what's the total cost of the wrenches? You'd multiply by what? 12, because it's a dozen wrenches. So that's the constant. So if you were going out to buy 12 wrenches, you would look at the different prices, you'd multiply by 12 to figure out the total cost. All right, suppose that M varies directly as Z. So that means M equals KZ. So do you see what I mean by if one goes up, the other one goes up? Like if Z was 5 and M was 20, when Z is 10, M's going to be bigger, right? So that's what we're saying. Okay, so M varies directly as Z. M equals 120 when Z is equal to 15. Okay. These problems will do this a lot of times where you're going to have to find the constant, so find K. So 120 divided by 15, you get 8. All right, and then you have to go back and you put that K value in. Because remember, it's a constant, so it's the same throughout your problem. All right, so it says write an equation and use this information to find the constant of proportionality. So this was our equation. We found the constant. So if I asked you for the direct variation equation, that would be this. Direct variation equation. Okay, and I'll ask you that a lot on your homework. So like, what's the direct variation equation? What's the inverse variation equation? All right, and a lot of times I'll ask you to find other values. So then I'll say, well, what happens if M is 200? What is Z then? So you'd have to find the new answer. All right, so the terminal velocity of a parachutist is directly proportional to the square root of his weight. So when you see directly proportional, that's terminal velocity equals K times the square root of his weight. So square root of W. So that means they're all on one line. A 160-pound parachutist attains a terminal velocity of 9 miles per hour. So 9 equals K times the square root of 160. Square root of 160 is like 12.649. So I'm going to do 9 divided by that answer. So when I do, I get K equals 0.7115. Now really, when you're in a math class, you should always keep these answers in your calculator, right? You shouldn't round. Like mine was 0.7115124735, and so on. All right, so I'm writing 0.7115, but I'm going to use that answer that's in my calculator. So it says, what is the terminal velocity of a parachutist weighing 240 pounds? So now we know our K. So we set up our direct variation equation with the V and the W. And now I'm asking, what if you weigh 240 pounds? What's the velocity? So do you think it's going to be faster or slower? Faster, right? This person weighs more. Okay, so times, so take your answer and multiply by the square root of 240. So I got V equals 11.023. Okay, and that was in miles per hour, just like the 9 was. So it's about 11 miles per hour. Okay, think about the graphs of these. So if one value goes up, the other one goes up, right? What kind of shape is this going to have?
Like going up.
Yep, it's just a straight line that goes up. So it's like a slanted line, I guess I should say, that goes up. So if y varies directly as x, so y equals k times x, and y is 27 when x is 6, find the direct variation function. So you have 27 over 6 equals k. So k equals 4.5. All right, so my direct variation function is y equals 4.5 times x. Now notice 4.5 is also 9 over 2 if you want to write it that way. Either way. Okay, so you guys told me that it's a line that goes up. What's the y-intercept? 0, right? Because it's like plus 0, plus 0. Okay, so it's like when it's in the form y equals mx plus b, the y-intercept is 0. And that will always be true for these direct variation functions. All right, so I'm going to start at 0, 0. And my slope is 4.5. In other words, it's 9 over 2. So do you guys see why it's convenient to write it as a fraction? So you go up 9, right 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2. So it looks like that. Okay, so inverse variation. So what I said earlier is inverse variation means if one value goes up, the other one goes down. All right, so they're not directly related anymore. They're inversely related. So this is going to look like y equals k, and instead of multiplying by x, we're going to divide by x. So k over x. That's a k. All right, if you think about it, if I put a really big number in for x, so if I'm dividing by a large number, y is really small, right? So you can think of pizza. If I'm dividing it into 500 pieces for a pizza, you're barely getting any piece of pizza, right? All right, so y varies inversely as x is what we would say. All right, so write an equation that expresses the statement. The speed r of Lance Armstrong is inversely proportional to the time t it takes for him to cross the finish line. So think about that. So the faster he goes, so the more speed he has, the less time it takes. So see how that's an inverse relation. All right, so speed r is inversely proportional, so k over t. So r equals k over t. Anybody know what k is in this case? Do you guys know an equation?
Of like the distance.
Yeah, it's the distance. You guys remember an equation that relates rate and time? It's distance equals rate times time. So if you had distance equals rate times time, if you wanted to solve for r, you'd divide by t, right? You have d over t equals r. That's what your k is. It's your distance. Okay, so anyway, so if y varies inversely as x, so y equals k divided by x, and y equals 4 when x equals 5, write the inverse variation function and sketch a graph of the function. Okay, so I'm going to solve for k, so multiply the 5 over, I get 20. That means my inverse variation function is y equals 20 over x. 20 over x. What does this one look like? Tricky, tricky. There's a reason we're learning it in this chapter, so think about things that we just worked with. Is there a horizontal asymptote? What's the degree on the bottom? The largest degree is 1, right?
Yeah.
You don't have any x on the top. So it's 0 over 1, so the horizontal asymptote is 0, right? So if you guys want to write yourself some notes, you can. What about a vertical asymptote?
0.
Yeah. x equals 0. So that's b when the denominator is equal to 0. So we know that we have those asymptotes drawn in. Okay, if you didn't know that, that's fine. If you didn't know that, do a t-table. Let's plug in, let's try like 5. If I plug in 5 for x, what's y? 4. If I plug in 4 for x, y is 5. If I plug in 2 for x, I get 10. If I plug in 1 for x, I get 20. So let's plot those points. So I'm going to have 5, 4, 4, 5, 2, 10, and then 120 is way up there. So do you see what it's doing? If I'm plugging in a positive x, I'm never going to get a negative y, right? They're always positive and positive. Okay, but what if I plug in negative numbers? So let's say I plug in -5, then I get -4. -4, I get -5. So it's basically the mirror image. So I'm going to have -5, -4, -4, -5, -2, -10. So it's like that. Okay, that's what an inverse variation function looks like. And intuitively, this should make sense. As you get closer, so as x gets smaller, so as I'm going down from my x values, what's happening to the y values? They're shooting way up, right? So as x gets smaller, y gets larger. Okay. All right, and then joint variation. All right, joint variation is a relationship among 3 variables, x, y, and z, written in the form y equals my constant, so you still have the k, times x times z. So if x and z both go up, y is going to go up. Okay, so this is an example. So the cost C of printing a magazine is jointly proportional to the number of pages P in the magazine and the number of magazines printed M. Okay, the biggest problem on these ones is people will forget their K. Right, you always have a K in these problems. So we have our constant. We're multiplying by the number of pages and the number of magazines printed. So basically it's saying like, oh, if it's 20 cents for a color copy for each page, you multiply by the number of pages in the magazine, then you multiply by the number of magazines you're printing. That's going to be your total cost of the magazine. All right, so that's our equation. Find the constant of proportionality if the printing cost is $60,000 for 4,000 copies of a 120-page magazine. So P is 120. M is 4,000. Your cost is 60,000. So I get K times 480,000 equals 60,000. So when I divide, I get K equals 0.125. Okay, so that's the cost of printing one page. So it's like 12.5 cents. So C says, how much would the printing cost be for 5,000 copies of a 92-page magazine? So K is this constant. It's going to be the same throughout our problem. So I replace it in my original equation. So I have 0.125 PM equals your cost. I'm trying to find C when P is 92 and the number of magazines is 5,000. Okay, so when you do that, it's 57,500. And the last thing we have is combinations of proportionalities. So this is a relationship among 3 variables, or even more than that, that contains both direct and inverse variation. So there's lots of different examples of this, but let's say y varies directly as x and inversely as z. You only need one constant. So we write y equals, so directly as x would be kx. Inversely as z, you divide by the z. So you just write k once. Okay, so it says the resistance R of a wire varies directly as its length, so that means it's on the same line as the resistance. So R equals KL. And inversely as the square of its diameter D. So the square of its diameter D. So it's over, because it was inversely, the square of D, so D squared. Does that make sense? All right, we are going to do a part of the next section too, but I'm going to stop this.